Hello everyone, this is the SMC Journal podcast. On this show, we talk about performance testing, tuning, engineering, monitoring, anything that has to do with performance in IT today, hardware or software, it doesn't matter. If it's about performance, we're talking about it. We're currently in the middle of a 4-part series. This is part 3, where we're discussing load testing fundamentals. And we just talked about in the first part, what actually is load testing? What is it trying to achieve for you from a business perspective? And it's really trying to make sure that your application can scale under load and performs under, for many, as well as it does under one, meeting these service level objectives, or what I call operational requirements, not non-functional requirements. A dog is not a non-human. It's a dog. Let's call it what it is. Performance requirements are operational requirements. It may function, but if under load it goes down, it's not operational at that point. So you've still got a problem. And that's what load testing, that's the value that it brings. We've talked about the load testing process in part 2, and we're going to dive into that. We talked about planning before, which is a really big deal. I wish I could have gotten into more depth about that and shown you some of the deliverables. But we're going to talk about the overall process again, but we're going to kind of break it down a little further. And to do that, we're going to bring up this slide. That this is the overall process, just as a quick review, that we are talking about planning, building, execution, and confirmation. Planning is the stuff that you gather to get these requirements of what we're, and the objective of what we're trying to do. Who are your users? What are they doing? How often are they doing it? What are the systems that I'm monitoring? What's it made up of? And then actually building that would be the automation of that. Execution would be executing the test, and then confirmation is looking at the results in analysis and making sure does it meet or not the requirements that we've set forth, and do we have a go or no go decision. So now what we're going to do is dive a little deeper into this and talk about some of the deliverables. This is my, Scott Moore's methodology for doing a load test for every project I've ever done. I share this a lot, but I've never isolated this portion of it and kind of went into this level of depth before. So we're going to talk about, like, when we talk about building, well, what are you building and what are the outcomes? What are the things that if I were a consultant and I went to an engagement, what are the things I would hand them before I left to go to the next engagement? What could they expect in a statement of work from me to deliver? That's really what we're talking about here. And in fact, if you are a consultant or you work for a consulting shop that does performance testing, these are things that you can put into your statement of work that says, here's what we're going to do for you. If you adopt this methodology, it's worked for me for over 25 years, and it will continue to work if it's applied properly. And let me say properly, meaning not being lazy, not cutting corners, doing it the right way. And sometimes that means taking a little longer or figuring out the best way to do it for this particular application. You might have to tweak it or tune it, but this has worked for me. So I'm not gonna change something that's working for me. Before we get into that, let's talk about our sponsors today. Our main sponsor for this podcast is Micro Focus, and they are the makers of LoadRunner Professional, Enterprise, Cloud, and Developer. It would be great if you checked out their community because it's made up of the largest group of performance testers in the world. Community.microfocus.com, scan that QR code, check out their LoadRunner family page and their YouTube playlist of performance engineering videos. We're also sponsored by the good folks at Keysight Technologies, who are the makers of Eggplant Performance. And Eggplant Performance is a load testing tool that has multiple protocols, including web, Citrix, and lower level TCP/IP protocols for like thick desktops, things like that. It also has controller, analysis, test results, all combined monitors, all in one tool to help you achieve your performance testing needs. Scan that code or go to eggplantsoftware.com. Check out the links that we've got on our show notes on the YouTube channel, as well as smcjournal.com. Every time we do an episode, there's a new page for that. We've also got another sponsor, and that is Total Performance Consulting. They provide the highest quality performance engineering, automation, QA, and development services possible since 2006. They have hundreds of years of combined experience with all of their consultants together in performance engineering specifically, and they've helped a lot of companies with their complex performance challenges, and they do partner with Eggplant Performance and LoadRunner, Tricentis, Neo, a lot of these products, they can use multiple products to achieve the goals that you have, depending on what you need. So if it's infrastructure evaluation, monitoring, setup, and analysis, performance testing in a CI/CD pipeline, many of these types of services, they're happy to help with, and they can help you and your company keep and get and extend your competitive advantage. So check out Total Performance Consulting at totalperform.com today. Okay, back to our slide here. Let's go to the slide that talks about not only the process, plan, build, execute, and confirm, but what are the deliverables associated. So now we're talking about the top right here. So when we're planning, you should expect, or if I was talking to a client today, I would say this is what you can expect when I'm doing this process. As I'm planning, you're going to be getting a project plan or a test plan, or you're going to get a set of user stories from me. I've actually got a pre-built template of user stories that I can import into a lot of the tools that follow this, that like online tools like Agility or Jira. We can import these user stories as a template and then modify them for this particular application and add what we want. It gets us there a lot faster. So that could be as simple as a spreadsheet or a Word document. You can start where you're at and then move into wherever you need to get to advance and progress in these deliverables is what I'm talking about. When I am done with the building stage, you could expect the actual business processes to be automated and in a way that they can play back with dynamic data. And when I leave, as long as you don't change anything for your application, you should be able to just push the play button over and over again, because I'll have these test scenarios set up, all the various ones. I'll have it all documented for you. It says exactly how you should run this. And then you can take that and maintain it going forward. You can call me back to help you with it again, or you can call somebody else to do it. They should be able to follow the same process because it's fairly standard in the industry to do things this way. Some people have their own little ways of doing things, and that's totally fine, but they should be able to build on what's been built here. From the test, you will get results that are native to the tool. In other words, if I ran a test in LoadRunner, it has its output from the test in the LoadRunner analysis. The same thing for many of the other tools. And then I may process that further. I may take that, put that into a time series database and visualize it with something like Grafana. However, I also include a report that would go to a wider audience, not as in-depth explanation of what they're seeing, but basically a summary of what they're seeing. And mostly I'm aiming at people on the business side who are trying to make a decision of what to do with these test results. So I would say this is sort of a minimum of what you should get. It's basically, here's what I'm going to do. You can see what I'm going to do. It's completely transparent. Is everything cool? You approve this plan. This is what we're trying to achieve. We've discussed all this, and here's what I'm going to test. Okay, I'm going to start doing it. I build you these perfect storms that's what I call a load test, and maybe I build you some scenarios that include stress testing or soak testing, running it for a long period of time. I'll get into that next, but I'll set all this up for you, and then I will give you as an output the actual test stuff in your test lab itself, so you can continue to run it. Now, if you change your application after I leave and you have to maintain your scripts because something broke, I will make them as modular as possible. I'll make them as easy to change as possible, but it's a fact of life. You're going to have to do some kind of maintenance on a script, most likely, if there's some major changes on the front end. If you make a change to a database index on the back end, you probably won't have to change anything. So that will continue to work. So we try to make it as maintenance free as possible on the automation side, but life happens. And then finally, you should get that final report as an output after we're done executing this test. And it's alongside, it's parallel. It's the test results natively from the product, and then it's a business report that summarizes that. And it's usually 8 to 10 pages tip to tail, and it's got a few graphs in it, but they're not very detailed graphs. They're more high-level graphs. And that really is a summary. That's kind of as I'm walking out the door, getting ready to go to my next project. It's here's what I did. Here's what we found. We worked with your team, and none of that should be a surprise because I should have been working with the team the whole time, giving feedback as I go, and they should have been working with me to help and maybe tweak and tune this application. Now, if we've got a finite period of time, we may not be able to do a whole lot of tuning before I'm on to the next engagement. So we have to scope what we're trying to do. There's other times where a testing engagement kind of turns into a tuning engagement. And this is where some of the newer products out there that do some tuning with AI and machine learning, things like Akamai and StormForge, that are very helpful to start analyzing and optimizing as you go, and let it run some tests and make some recommendations to make changes, so you can get the tuning done in just maybe a few days versus weeks of manually running these tests, analyzing it, looking at it. I mean, those days I think are pretty much gone at this point because we just don't have the time to do it. So all that said, those are deliverables that go with the process that I'm describing. And then finally, we talk about execution. So let's go down to the bottom right, where I mentioned these 6, what I would call major execution scenario types. So when I say scenario, a lot of times a functional automation engineer will say a scenario is from the time a user logs in to the time a user logs out. I would call that a business process. They call that a test scenario because they're only testing for one. I'm talking about orchestrating an entire test where we have multiple business processes where users are logging in at different times, going to different places, pausing for randomized times, always submitting unique data, working the database hard, and then at the end of that, how do I ramp them up? How fast do I ramp them up? How long do I hold them at a certain level? How long before they ramp down? And when I look at the analysis, do I keep the ramp up and the ramp down? Do I chop it off to get more accurate numbers under load? That all depends on what my test objective really was for that execution type. So for a functional person, they're going to run that test, and it's pretty much, did it pass or fail based on functional requirements. When I press the button, did I get an error? Is the button blue? Does the button say button? Does it say login? What is it doing what it's supposed to do, but is it not doing what it's not supposed to do? Understood. But then as we run this load test, there's an orchestration of the behavior of these virtual users, of how they act during the test, and there's multiple processes to consider, and sometimes there's dozens of business processes to consider. So let's run through these execution types. This right here really, if we talk about, I've mentioned my secret sauce several times. This really is the secret sauce to the methodology, because once you've built all this stuff, if you've built it as accurately as you can, and you're running it on an environment that is as close to production as possible, there's always going to be things that are different, right? There's a human element involved as well. There's configuration settings. There's all these things that something can be missed. But if you just try, you're going to get it as close as you possibly can, and you want to create the type of behaviors and load levels, peak conditions. You want to create that as much as you would see it in production as possible. If you've never released this application to production, you may not have that information, and you may have to at some point just go on gut instinct on some of this based upon what the business has told you they expect and why they expect that. An educated guess is what I mean. But if you've had this application for some time and you've got logs to go by, production statistics, and the peak times, the peak usage, it's a much easier way to calculate what these load volumes and things should be. But let's just start at the very basic here. We've got this baseline. Now, baseline, these words, I'm not going to play a semantical game with anybody. I'll tell you what I think these mean to me. A baseline would be, does this business process meet the service level agreement based on user experience and system resources? Does it meet these requirements for one? That is a baseline, because that is as good as it's going to get. If you've got a pristine lab environment, a pristine application under test environment, you run a single user, and I don't mean once, I mean run that user, pause a couple of seconds, run it again, run it with think time. Do everything that a normal user would do at the kind of the pace a normal user would do. Put some randomization in there so the pause times are random as well. Put some pause times between the amount of time it waits before it does the next iteration. And kind of pace it out and let it run for, 15 minutes, 30 minutes, an hour. I let mine run for a whole hour. And then I get the average and the 90th percentile and the 95th percentile and all those great numbers, and I look at it and I say, okay, well, this is as good as it's going to get. And if under that single user we're seeing 15 seconds for a search, okay, game over. There's no need to go any further than that. We report back the feedback and we do something about it, right? I mean, that's really, that's the best way to do it. We don't want to run through all these tests and go, well, it failed at 15 seconds. Now let's run a 500 virtual user test. It's just going to get worse. Let's deal with the problem and not wait till the very end, and then it's a surprise to the business. Well, why didn't you tell us 2 weeks ago when you first started testing, or a week ago, whatever that was? We could have made a change. I don't know why some people don't think that way, but they do. The next thing I want to do is to make sure that my scripts and that my automated business processes do have the right kind of dynamic data and what I call correlated data in them, and they're not going to step on each other in a bad way. I will run 3 to 5 in a mix of these business processes, and really that's a test of the test. And that's not really mentioned in here, but it's basically I'm doing a baseline of every single business process by themselves, and then I kind of mix them with just a few. And I don't really count that test, because what that's really going to tell me is if I run 2 virtual users, did I set the parameter value for the login to a random one so it chooses a different one each time, or a unique value? Or did I stupidly set the configuration so every person logs in as the very first user in my parameter file? So user 1, then this virtual user logs in as virtual user 1, and while this one's logged in, so you've got 10 virtual users that are all logging in with user 1. And that's not reality, because when those users, even though an application might allow you to share those user IDs, there are things that happen on the back end sometimes in databases and caching and session values that it just kind of steps on each other, and you'll end up chasing rabbit trails that wouldn't exist in production. So that's why you want to run that way, and just do a test of the test. We'll call it that. So then we move on to the next, the second one, called the top time transaction. Now, I learned this when I was learning, not LoadRunner, but there was another product that was added after LoadRunner that was more of a tuning type product. And the name escapes me right now, but we actually had somebody come in and walk through this class. And this is where I learned about this. It's like, okay, well, you've run one. Your goal might be to ramp up to 1,000 users, but how do you know just off the bat that somebody hasn't set up a very small, weak set of infrastructure, and that your environment just really isn't ready for that, or the configuration settings just really weren't ready? Maybe somebody went to the web server and said, just accept up to 100 concurrent connections, and just start failing over at that point. I mean, you don't know any of this going forward. You find that out as you go. So instead of just biting off from 1 to now we're going to ramp up to 1,000, I try to go for about 20% of that value. So I'll ramp up to 200 users over a period of time. Normally my ramp ups are going to be around 20 or 30 minutes for users that are, if it's a 1,000 user test or less and it's web, depending on the protocol, it's usually about a 20 or 30 minute ramp up. Let's just assume that's what it is. I will still do that 30-minute ramp up just for 200, just for 20% of that load. I'm really paying attention to the ramp up at that point, because I want to find out, have we bit off more than we can chew? If we can't make it to 200, there's no reason to run a 1,000 user test. So you see what I'm doing? I'm doing it in levels, but I don't do it for 1 users, 10 users, 20 users, 50 users. There's no reason to do that. You just need a couple of data points for that. So I ramp up to 20% of my expected peak load value of 200. If we make it through that, that allows me to analyze the system resources, because you should be monitoring all of these system resources at the same time in a real-time dashboard where you're looking at the number of users running, how long the end user experience is taking, and how it's affecting the system resources. So are we thrashing the database? Are CPUs giving out faster than we thought? Has auto scaling kicking off faster than we thought? All of these things you'd be able to see as you're ramping up at this 20% level, and you can kind of gauge, well, you know what, we're really hitting this thing harder than we really want to. Maybe our users are running too fast. Maybe we aren't doing the right things, and this just gives you a good checkpoint without completely destroying the system first out of the gate. So then we get to this word benchmarking on the list. So with benchmarking, that's what I would call getting to my full load of, let's keep it at 1,000 users. I ramp up to 1,000 users. I can make it there and things aren't crumbling. I'm not getting errors on the app. The infrastructure is holding fine. And I hold it there for an hour after ramp up. That's not including ramp up, a whole hour. And then I will ramp down. Now, depending on the number of users, the protocol, is how fast I might ramp down. But really what I'm trying to do there is I want to look at the ramp up. But if we have made it that far, or let's say we don't make it that far. If we don't make it that far, my test result will include the ramp up, because I want to see at this point, at 452 users, that's when you went off the rails. And this is why, because this server is doing this, this resource is, needs to be replenishment. We've depleted it, and boom, it's down. We started queuing, whatever that was, you pinpoint it. But if you do make it to 100%, then what you want to do is chop off the ramp up and chop off the ramp down. Now, why would I want to do that? I want to do that because the numbers that you're getting at 1, 10, 20, 50, 250 are going to be better than they are when they're at the full 1,000. We want the snapshot of the 60-minute window at the peak value of 1,000 users. I don't want to average in these numbers. I don't want to average in the numbers ramping down. So I would hope that if you're using a good load testing product, it will allow you to do this in analysis by scoping that window out and saying, okay, my ramp up was 30 minutes, and then it took me another 30 minutes to ramp down on the end of it. So my test took a total of two hours. I chop off the first 30 minutes, the last 30 minutes. There's my snapshot right there. That 90 or 95th percentile, whatever number you like to look at, that should be as accurate as it's going to be. And I would call that sort of like more conservative and a more worst case scenario number as well. If that's still within the service level objective, you're probably pretty good. Okay, so that's what I'm looking for, and that's what I would call my benchmark. And if I can meet that, okay, well now you guys, change some stuff on the application, change some things in the database, do whatever you want to do. Now let's rerun that same test, do the same snapshot, cut this thing off and see, does it get, that's when you can begin to start making trends from that. Now, some people would call that something different. Some people wouldn't call that a benchmark, but that's what I consider a benchmark. I don't consider one user as the benchmark. I consider that a baseline to work from. And I know that's as good as it's going to get. And 1,000 users are probably going to be much worse than that. Most of the time, that's how it works. So if you make it that far, let's go back to the graphic here. Scalability. Now, this can mean something totally different to whoever you're talking to. Scalability would be if I've already talked to my client and they say, we expect 30% growth over the next 12 months. Well, I'm probably going to run 130% of peak load. So instead of ramping up to 1,000, let's make sure we can get beyond that by another 30%. Let's ramp up to 1,300 virtual users. Now, if you're dealing with license issues, this is where people are like, well, we only bought 1,000 virtual users. We can't go above that. You got to plan for scaling beyond that. In fact, I would say that in a perfect world, every application would scale 2x of the worst possible conditions expected. So if we expect the worst possible conditions to be 1,000, let's plan to meet 2,000, right? So somewhere in between there, 120, 130%, 150% to 200%. I will run one of those scalability tests. I won't run a bunch of scalability tests. Just pick one. Okay, well, 50%. Can we handle 50% growth and still keep the same servers for the next year? Let's find out. So we ramp up to 1,500 users. In that case, I probably would still use a 30-minute ramp up, 30-minute ramp down, snap it off, compare the 60-minute window to the 1,000 user test. What's the difference between them? And so why do I choose in 60 minutes? This is my philosophy. Argue with me if you want. I think it takes about 60 minutes to watch the system run. And if you can meet the 60-minute window of the peak hour of a day, you can probably meet the other 23 hours that aren't peak in the day. Now, I know you could say, well, if you could meet the peak 15 minutes of the day, you could meet the other 15 minutes. Okay, but there are things that happen on certain intervals. Say there are logs being dumped off on servers, a database is doing some things periodically throughout this. You want to give it enough time for these back end processes that may be automated, maybe in the operating system, back in jobs that you don't even know about. You want to give them a chance to run through as they're dealing with processing all of this load that's happening really. And I find that if you go too short, if you go to a 15-minute test, I don't feel like you get a good enough window with that. So that's just me. Take it with a grain of salt. So volume or soak testing is next. With soak testing, it's pretty simple. It's if you could meet the benchmark at 100%, and now you're really confident. Hey, we did it at 100%. We did it at 150%. We're still good. System resources are good. Okay, but do we have a slow memory leak that we haven't found yet? That we won't find until 3 months after we rolled it out into production. And then we're going to start getting called in the middle of the night somewhere. Oh, guess what? It's down and we didn't know about it and observability tools didn't catch it. I mean, in a perfect world, they would, and they would do something about it. But to make our lives easier, why don't we just take that full load test, that benchmark that we've been running and we're good on, run it for 8 hours, run it for 24 hours. You're in a lab, you can do it. You got to make sure you have enough data to run that long. You got to make sure all that stuff is prepped. But if you've got it, run it, and then you will begin to see things that will appear over that long period of time holding at that load level, because it's not going to hold at that load level in real life. But if you hold it long enough, you will begin to see these patterns emerge where if you did have a slow memory leak that would take months to be exposed, you'll see it within 24 hours. And then you say, we've got a memory leak we need to deal with, and here's the transaction that's being affected, and oh, here's the code within that transaction, within that URL request, for example, or this API call, right? And then you fix it at that point. Or every time we do this, you know, we missed an index on the database. Let's fix that index, and it just, whatever keeps getting worse. So that is the soak testing scenario. And then finally, we have stress testing. Now, I always say that the stress testing test scenario is optional because it may or may not be very useful for you. For example, if all you want to do is find out the first point of failure, which is the objective of stress testing. Let's take all the think time out of the users. We got 1,000 users right here ready to go. Let's just remove all the think time and just pound this application and confirm how long before the first failure happens and what tier would that be at. You would assume maybe it's the web server because you only have one web server in your lab. Okay, if you prove that, you probably can do it in about 15 minutes or less. Yep, the web server is the first thing to crumble. 503 server busy, my favorite error. Okay, so what are you going to do about it? Well, we don't have any more web servers. Well, you're going to need a couple of more web servers. Let's load balance them. Let's see how much further we can push it. And then guess what? That might push the bottleneck back to the second tier. It may push it to the database tier at that point. Oh, well, now we need to be able to scale out the database, or we need to scale out whatever that might be. You'll see the bottleneck move, but you have to be prepared to make infrastructure changes to deal with whatever you found that goes down first. Just makes sense. So if you're not prepared to do that, you can run a stress test, run it really fast and say, yep, this is the first point of failure. This is where it's going to happen. So if you want to deal with that now, you should probably go ahead and do that. I always tell people, though, if you're going to have to shoot for one or the other and you run out of time, focus on the load test. And then people will go, oh, well, isn't a load test the same thing as a stress test? And then we get back into the semantics because a lot of people think it's the same. So you have to then define stress test being finding the first point of failure, load test meaning we want to, and I keep using the term, perfect storm. It's what we really think would happen in production, but under the worst possible conditions. Stress testing is not real world conditions, it's artificial conditions. So in your load testing planning, if you don't plan properly, you could be creating load test scenarios that aren't realistic at all. But that's why you have to do your due diligence to try to make it as realistic as possible. And so that's what I do. And as I go through each one of these stages with the baseline, the 20% test, the 100% test, the 150% test, the long test, the duration testing, and then all throughout that, I have the ability to raise the red flag and say, hey, we found a problem. We should stop here and look at it if we've got the time. Now, if we don't, if it's like, look, just get the testing done, tell us what you need to know, and then we'll take it from there. I mean, that's fine. I mean, I have been under those kind of conditions before. But if you've got the time, you want to have chances to say, well, let's run another test, make another change, run another test, make another change, run another test, and let's make sure that we've got everything out of this application we can get out of it. If you run out of time because you've spent so much time focused on being the best technical automator and code writer available, and you lose time on the back end of your project, of that time trying to get testing, I would rather have more time testing to find and fix things before I had to leave to go to the next engagement versus focusing on why something doesn't work in this add-on tool to thing of. And this is one of the reasons why I always talk about it. If you've got the time to build the perfect, what I call Rube Goldberg machine, if you don't know what that is, look up Rube Goldberg machine. If you've got the time to build that perfect thing, you can probably find a lot of free tools out there that you can put together that will do exactly what you want it to do. And if it doesn't, many of them are completely open source, and you can write your own code to make it do that. But while you're doing that, a consultant like me who only has a limited amount of time has to come in, get it done, and get out. That's because they're paying a lot of money for this. So you're actually saving money by going and buying a commercial tool that has all the stuff you need without any add-ons, hopefully without any add-ons, and it does everything that you need with all the protocols, with all the outputs, and makes it easy for you to do this process that I'm talking about. You get the testing done and be able to hand that over, and it be something that can be easily documented, or maybe it's a standard out there in the industry. And then if you do have a problem with it, to be able to have support that you pay for that you can call and actually get the help that you need to fix the problem and move forward in case there's actually a problem with the load testing tool itself. I know that seems impossible that could happen, but yeah, load testing tools have defects in them as well. So choose wisely on the tool set that you have, because your time is worth money as well. I know, and that's whether you're an employee or a consultant or whoever you are, your time is probably the most valuable thing you have. And you're not an open source human. You have to work to make money, to make a living, and hopefully you enjoy doing what you do. But it comes down to, we don't all work for free. And what I don't want is a business to spend more money on me just as the time that I'm going to spend setting all this stuff up to get this process that I've outlined, this methodology, which should be completely tool agnostic, to work. Versus, oh yeah, well, you got to pay me, it's going to take me 3 times as much to set this up and document all this stuff, because when I leave, nobody else is going to know how to do it except me. You're going to have to maintain it, and if you need support, you're on your own, or you're going to have to find some help somewhere and hopefully find that person who's experienced the same problem as you, etc. You see where I'm going with this? I'm not making a theological debate out of an open source tool versus not using an open source tool. What I'm saying is, when you're in a situation where you've got your time versus business value, you have to weigh that as to what you choose. And you have to be the person that makes that decision, and hopefully you make the right one. But in any case, this methodology that I've outlined for you over these sessions, it works, and it should work with any tool that's out there. So that's today's broadcast. What do you think about that? Can you shoot holes in this? Have I messed up anything? Now, I've talked about execution today, but the next episode, part 4, we're going to talk about analysis and what should be an analysis, why we monitor and what we should get out of that, and why we want to combine good analysis would combine the system resource monitor, other kind of monitors in with end user transaction times that typically come natively with any load testing tool. So we'll talk about analysis in the next part. Meanwhile, if you want to give me feedback on these sessions and what you think, contact me at scottmoore.consulting through my website. You can reach me on LinkedIn, Twitter. You can email me at help@scottmoore.consulting, and I would really appreciate it if you do like this to subscribe to the YouTube channel. Let me know that you like what I'm doing, and tell me about some of the other stuff that you'd like to see. And would you actually like for me to create a full-fledged class on this where we kind of get into more depth, and we show you kind of examples of some of these deliverables and outputs that I'm talking about, as well as taking this process and then having separate modules maybe per tool, where we go through different protocols and use sample applications, and we walk through step by step how I would apply automating these business processes for this product, and then how I would apply that to this methodology that I went over. Love to hear your feedback, and contact me about any other subject that you'd like to see on this show, or who you'd like for me to interview, events that you would like for me to cover. So look for me out on the road. You can go to theperformancetour.com and find out what's going on with the Performance Tour. We've had and will have several meetups throughout the country in the United States as I'm able to get out and go around, but would love to hear from you and possibly meet you out on the road. But until next time, this is Scott Moore for the SMC Journal podcast. Thank you for watching. We'll see you next time. Bye-bye.